Okay, so today I'm going to review and update my experiences on my 3D printer. Um, my model is the Prusa i3 Tarantula. It's by Tevo, and the print bed I upgraded to the 280 millimeter as opposed to the stock 200 by 200 millimeter. So it gives a little bit longer print bed. Uh, the frame is aluminum, uh, 20 by 20 and 20 by 40 V-rail. It's a T-slot, so you can basically put in T-nuts and basically slide and tighten down items, kind of like a track system. They don't tell you a lot of stuff when you get this printer. When you get the printer out of the box, it's not ready to print straight out of the box. You have to build it. It's a kit. Um, you, they suggest it's supposed to take around maybe 6 or 8 hours. It doesn't take 6 or 8 hours. It took me about 4 or 5 days. Not solid, but periodically I would be working most of those days on just researching how to build it, fine-tuning, stopping sway of the frame. When you're trying to build it, you pretty much have to align everything so it's not off by a little bit, otherwise you strip screws, or you bend the frame, or obviously your print doesn't come out straight. When you're printing, you also have to control the speed that the motors are going at all directions. So fine-tuning software-wise, I scrapped the stock firmware and uploaded Marlin, which works great for me. Other people use Repeater or a couple other ones I don't remember, but there's about 4 or 5 different firmwares on the internet for these MKS boards. Some other boards are included on this model, but it works good. I've wrecked a lot of filament. The filament is basically the material that gets pushed through the heated element at the end of the print head, and the motors control back and forth and which way the motors go to spit out the filament in a sort of icing layer format. So that's generally what 3D printing is you basically layer, 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 and then move up, layer, 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 move up. A lot of learning, a lot of patience and frustration, and yeah, it's fun. So next is reviewing what I've printed so far. Game Boy cartridges. I have about 21 of these things because I have the original DMG, and then I have a Game Boy Color. And I like video games. I like video games. So the first print of this didn't work. I believe it was something like this. It spat out some filament, and this is obviously an over-exaggeration. The fill pattern, it's not solid. You're layering, and then inside you have the option to have different patterns. So you would have honeycomb, you would have linear, which is basically like my fingers, and then rotate, they would print that kind of style. The original one lifted up a bit on the end, and it looked like crap. It would have basically had this kind of tilted up and bent this, and this little slot here would have been closed off. So that was not a very happy moment in this experience. This one is pulled directly off of Thingiverse, I believe. Thingiverse.com, I believe. Yes, Thingiverse.com is an excellent place for free, royalty-free models, as long as you give credit to the designers, and you don't sell it for your own personal gain. They really don't like that. It's kind of like selling people's art at a face value plus profit on eBay. You just, it's unless you give credit to saying, you know, this is designed by this person. If you're saying that's yours, that's not cool. But yeah, this was free. The design was free. I downloaded the file, and for the most part, this fit until I reached at the back here. And one-handed YouTube-ness. I can't speak. This one just, whoops, yes, fail. This one does not fit in here. This is printed at 100% resolution. The tightness of the cartridge is very, very snug. So what I did on this model, which failed, that's the, just noticed that there, that's the linear pattern, but this one failed. It pulled up a little bit and basically did the same thing as the first version. So I kept this as a coaster. It was fun. But yeah, what I did next was I printed it at 112% in Slicer. Slicer is the E replaced by the number 3. It's free software to control via USB into your computer to show this how to print whatever you're printing. So you load the file as opposed to putting it into the SD card, which is in the side of this controller here, and it would basically, you know, spit it out here. Instead, you're controlling everything directly from the computer. So scaled it up, exported it as G-code, and that's the format that the pronterface or printerface for Mac. Mac is pronterface, PC is printerface. Basically, it would spit this out into the USB, and then controller board would say, oh, okay, this is what I do, move this across and print it out. So scaling up, this actually fits a lot better. I will do something very dangerous, and see, it fits. So very, very loose, but still stands them up just fine. But yeah, some other stuff I printed. I didn't print glue, don't worry. I tried printing out a Hello Kitty figure for a friend as a joke, and it also has, like the Game Boy holder, honeycomb as an infill pattern. It failed, and I think it was because I ran out of filament, or I ran out of time, or I don't know, but it makes an amazing tool holder. Recycle your parts. If you don't need it and you're going to throw it away, reconsider and think, would this be useful? I mean, 3D printing is, to all intents and purposes, using recycled plastic, as long as it's clean. You can't have any debris or anything in the plastic when you create your own filament. It has to be perfect diameter. There can't be any sort of particles that are foreign material other than plastic, because if you do, little nib at that end there that's brass has a 0.4 millimeter thick diameter hole. Now, I don't know if I can focus this, but there we go. Kind of. Alright, so the drill bit that's sticking up in the middle of those two tall ones, right there, that one is larger than 0.4. If you have a little particle or stone or piece of metal or something that got melted into the plastic, it will clog that, it will jam, you'll wreck this device here, which basically is a gear motor that pulls the filament from your reel of filament into this and pushes it into that tube. This is heated up, you jam it up, it's gonna kind of shove through there and make a mess. If you Google jammed printer head 3D printer, you'll see a lot of messy photos and stuff of burnt metal and such, it's a big headache. So has to be clean filament. Don't get really crappy quality. That will bring me to my next comment about this review. If you have good quality filament, the flow will be great. You won't have any jammed up printer heads. You won't have to replace components, and you'll be happy. What was I gonna say? I forgot. I'm old. Anyway, this is also an opportunity. I rarely do endorsement videos and such, but these guys are absolutely amazing. I live in Toronto, so these guys here actually are local to me, kind of. It's a bit of a walking distance from my transit system, but these guys, I will probably flip that, there we go, filament.ca. They have a very wide selection of filament. This one here, it's a kilogram. It cost me $30 plus tax. I got two. This will last probably at least, I think they said 160 or some odd chess pieces worth of design. So you print tons of stuff. You can print big stuff, lots and lots of things, because you're not printing 100% solid. This little bit here, people will think, oh, that's sealed in, that's like a solid chunk of plastic. No, that basically is like 20% inside of that frame right there. That's 20% infill. So that's how you save cost. You don't print solid design plastic form. You print a very thin layer of a wall, and then the rest of it is just an infill pattern. So it's good. It's not hurting the environment by using a ton of plastic, and plastic's recyclable. This stuff here is actually PLA, which is often used in non-toxic, biodegradable bottles. It's, I think, a sugar base. So it's not like ABS where you have different petroleum-based chemicals in there that will have noxious fumes coming up at you when you're printing. I haven't printed an ABS yet. I might, but we'll see. I have to basically build an enclosure and then have a fan vent out of my window with a pipe in order to do that, because I have cats and I'm basically working right close to this. I don't want to breathe in ABS fumes when it's melting, because you have small particulates that are going into the air when you break down ABS, and it's poisonous to breathe. It's bad. So safety, safety, safety. Oh, next, this stuff is awesome. People say, oh, use painter's tape. Painter's tape on the bed, it basically gives a better stick, because you can't have a very smooth surface. Any finger oil will cause your print to lift. That was why this first version failed. When I did the first version and a couple other designs, let's see if I actually have some of them here. You can laugh at it and say, what the hell do you print? Here, that's actually the first version. Now, you'll see this lifted. That is bad, because when you lift, it contracts. This is a form of surface tension. Basically, I've learned that when plastic cools, obviously it's heated, it'll expand. When it contracts, it will, or when it cools rather, it will contract. So the tension on this, if it's cooling this way and it's a long object like so, it won't do so much now, like from that direction, but it will contract a lot more this way, because there's a lot more mass this way. So contracting that way, not enough stick on the bed, it will lift, this area will squeeze, these won't fit, your design will look like crap. So reading online, they said Elmer's extra strength, water soluble, non-toxic glue. Now you can actually melt this into water, make a bit of a slurry as well, and paint this on with a very clean, smooth brush. You won't even need to use this in most cases, but usually you will on larger pieces, because you'll have to get a very fine edge, lift it up, and then peel it off. This sticks very well. If you leave it overnight after a print, you might have to use a little bit of force in order to pull it off the bed. This was one of my first prints. This is why you have to calibrate, because it will say, okay, so how big is the filament going in? How much do you want to squeeze out? And this is the amount of force that this thing will have to push. This is the amount of temperature that this will have to let this be pushed through. And then this is the height that this will squeeze down while it's moving around. And I think I set it to something stupid like 3 millimeters or something, and saying, oh yeah, it's going to push through, and it just went and made spaghetti. That was fun. Still haven't gotten this entirely done yet, but this is a calibration, so when you're crossing over areas, it's supposed to work without infill. You're basically going to have a flat surface like so. It's basically, I believe, the speed that it travels across point to point. It shouldn't need supports, it should have a smooth surface, but if it does, it does. If it doesn't, then you're printing big stuff like this that doesn't need bridging, which is what that's called. Then you don't really need to configure it yet. You should, because you might run into designs that are going to crap out. This is handy. I found this on Thingiverse as well. It's a SD card holder. It basically hooks on anything that is the same, roughly, thickness as your plexiglass holder that came stock with this printer. That's the controller board, so kind of the motherboard of the printer. It is an Arduino based computer board, so it runs Marlin firmware, any of those other ones that I mentioned earlier, and you can calibrate it using the Arduino application that many robotics and hobbyists use for Arduino based items. The first problem that I had with this was a hardware issue. Now, I can't really see from this angle, I don't really want to bump my print while it's doing its thing, so I will use this one as an example. This is a Limit, Lim -IT, if I remember correctly, switch. And what this does is that little toggle there, you'll see a little red button, finger there, right in set there. This will basically go wonk whenever it hits that board, and if it hits right here, and that will say, okay, stop moving this way. This thing is probably about, I'd say, a pound of metal, and it rolls on these little casters, bearings, whatever, and there is a mount there that rolls that screw on that motor. So the motor carries this all the way up, or all the way down, The switch down there I had set too low. So what does it say when there's no switch to say stop moving and there's still an object in the way? It goes crash. I cracked the board here, and that was from pulling down, and it went, and basically it was wobbling out there. It was a very sad day in 3D printing land. So I basically used a chemical called Weld On 16, which they only sell, I think, in one place in Canada, or in Toronto rather, maybe in other parts of Canada, but at least in Ontario It was only one place called Plastic World. Also a very cool place. I believe they're west of Downsview Airfield. Um, Cost me about maybe $6 or $8. And Weld-On 16 is a solvent. It basically welds or melts the two pieces of plastic, be any kind of acrylic. I used a portion of a CD disc, jewel case rather, and just carved off a piece and stuck it there and sandwiched it together. It's been holding fine for about maybe 2 weeks now. Always position your end stops, which is what those are, the limit switches. Always position them properly before you start moving anything around, and make sure that the bolts are actually secure. These can slide if they're not tightened properly. Where is one that I can show you? Well, kind of here. If you look inside there, not really. Okay. Well, a T-nut is basically a thing like that, and then the bolt goes in like so. The V goes along the track inside here, so like so, and then when you pull it up, the edges kind of go bumping on the edge there, so it pulls up and locks whatever you're pushing down on. Google T-nut. It's a lot easier to see than to explain without one. But that switch was not mounted properly. It slid down. It said, "Okay, I'm just going to keep on going down," and it went crash. It was fun. So always check those and go slow. That's my advice. I was in a bit of a rush. I was excited. Oh boy, 3D printing, and it caused me a stop and learn. Some other stuff, I actually replaced, well, I'm going to replace that bracket with this little carriage that is the bottom piece on that screw rod. And, whoops, I'll clean that up later. That piece, which is basically a replacement for the one that broke. So that will basically sit like so. Motor would go on top, and this would basically angle in and hold that. Good device off of Thingiverse. Yay. I actually got a different one of these. I didn't like these ones. This has got to do, I think, with travel speed. I'm still researching on that, but I didn't like this device just because it's not easy to grab onto. These little bits here are tensioner nuts that the spring contracts or loosens and levels the bed. Because if you don't have an exactly level playing field, you're going to have a little bit of a slant, and it's going to be, different layer thicknesses, wobble, messy. Fan grills. And soon, when it comes in the mail, a LED strip I'm going to basically mount on the underside of the fan on the extruder, which will enable me to see at night when I don't have the lights on. I will be able to see the print going and monitor that a little bit better. I have really bad lighting in my room, so yeah. Anyway, what else is there? I think that's it. Some other failed prints. You can see some variation in the infill. That also has to do with travel speed, but I cleaned that up. Anyway, all in all, I am pleased with this. It took some time to calibrate, but it works. So thanks for watching, and subscribe, like, rate, and have a good day.